Sometimes things do not go according to plan and we need to reverse some kind of actions that were executed. In other words, we need to compensate for things. Let's look at an example. Here we have a purchase order handling process where first we check the purchase order and then in parallel we handle payment and we fulfill the purchase order. That means sending the goods. After that, after both are done, we send a message that the purchase order has been handled. So we actually sent the goods. However, imagine that the customer can cancel the purchase order at any time. Let's say that we are a very friendly organization, very customer focused. So we're going to do whatever we want, whatever we can in order to assist this customer with canceling. So the customer can cancel at any time. We do that using a compensation construct. And a compensation construct, let's first look at how we can handle a thrown compensation. So we can do that by adding a boundary event to a sub-process or to an activity, and then adding a so-called compensation handler. Notice that this is not a sequence flow because the handling only occurs when activity has already finished. So there is no more token in activity when we want to call this handler for compensation. In the handler, we have this little rewind icon. And of course, the boundary event also has a rewind shape. We can also do this on non-sub-processes. You can mix them arbitrarily, both for the handler, of course, and the activity that you want to compensate. So what does this mean exactly? Only when the activity is done and after that the compensation is triggered, then the compensation handler is executed. There is no flow and there is no flow out of the compensation handler as well. So we only have this association. So there's no sequence flows going in or out of this compensation handler. So you cannot keep modeling there and then later merge it into another path. No, it needs to be one task or one sub-process. Let's look at how to trigger compensation. There are two options. First is the intermediate event. Notice the filled rewind icon, and on receipt of a token, this will activate the compensation. We also have an end event that works in the same way, except after the compensation is done, the process will end. Now, you might want to cross compensations. So you might want to have different activities doing different compensations and trigger them in different ways and at different times or in different circumstances. That is possible. You can give these labels. So if there is no ambiguity and it's clear from the context which compensation event triggers which compensation catching, then that's fine. You don't have to use labels. However, if it is unclear or ambiguous which compensation you throw and which activity captures it and is compensated, then please use a label. If it is ambiguous which compensation belongs to which catcher of compensation, so which activity must be compensated by which throwing compensation event, then you can use labels. And if you use labels, that means that only those with that label will be compensated. Let's go back to our example. Here we have our example again of handling a purchase order. Now we need to compensate because, as we said, we want that the customer can cancel the purchase order at any time. So for handle payment, we add a boundary event. That is this one that tells us that the subprocessor can be compensated. And we give it a label, cancel purchase order. Attached, using an association, is the reimburse compensation handler. So this means that if we throw cancel purchase order and the payment was already handled, then we will reimburse. So if the payment had not happened yet, wasn't complete yet, then even though this compensation event will be thrown and catched, the reimbursement will not happen. So that's kind of magic. We do the same for fulfill purchase order, where we add the same boundary event based on cancel purchase order, and then we have a compensation handler handle goods return. Again, only when fulfill purchase order has completed and then the compensation arrives, then will we execute handle goods return. We still need to throw the compensation, and we do that on receipt of a message because we need to compensate when the customer cancels the purchase order. So we add a boundary event to the handle purchase order, and that will stop execution. So on receipt of a message of purchase order cancel, the whole sub-process of handle purchase order will be cancelled. Then a token will arrive at this cancel PO end event, and that will trigger the compensation. So notice that this handle purchase order is not there anymore when we execute the compensation. It will, in this situation, by the way we modeled it, it will only compensate if the enclosing handle purchase order is not present anymore. To counter that, and to make sure that there is enough still information to reimburse or to handle the goods return, the data that is present at the moment of completion will be preserved for the compensation. That wraps up compensation. We've shown that you can handle it using a boundary event, an association, and a compensation handler, and you can throw it using an intermediate or an end event. Compensation is very useful in order to undo kind of effects of tasks that have been executed, and they will not be executed if the task had not completed yet. So that means we don't need any complex machinery in order to undo things that were done earlier in the process.